Okay, so for the final video for section 5.4, let's verify the following identities. So for example, we're going to use a product to sum and sum to product identities to verify. So verify the following. Verify the following identities. So number one, let's verify that 2 times sine of 2 theta times cosine of theta minus sine of 3 theta all over cosine of theta is equal to tangent of theta. Okay, remember we start on the ugly side. So 2 times sine of 2 theta times cosine of theta minus sine of 3 theta all over cosine of theta. Actually, I might need to move this back a bit. Okay, so I claim that this is of the form sine alpha cosine beta. So I'm going to change this product to a sum. Now, sine alpha cosine beta. Let's go back. So sine alpha cosine beta, this is this third identity here, so it's 1/2 the sum of the sines. Okay, so it's 1/2 the sum of the sines. So I can rewrite this as 2 times 1/2 the sum of the sines, that is sine of the first angle plus the second angle plus sine of the first angle minus the second angle, from which I'm subtracting. Actually, I might need to move this down. I don't think I have enough room. Okay, so from which I'm subtracting sine of 3 theta and dividing that all by cosine theta. Okay, so what was the first angle? Alpha. Boy, I still don't have enough room, do I? It was 2 theta, from which I'm adding and or from which I'm subtracting theta. Okay, so what do we get? The 2's reduce. So I end up with sine of, looks like 3 theta, plus sine of theta, from which I'm subtracting sine of 3 theta, and dividing the whole thing by cosine theta. Okay, well notice now that sine of 3 theta sum to 0, and I'm just left with sine of theta in the numerator and cosine of theta in the denominator, namely sine over cosine is tangent. So we have established the identity, check mark. Okay, let's do one more for good measure. So number 2, let's establish that sine of 13 phi plus sine of 7 phi, all divided by cosine of 13 phi minus cosine of 7 phi is equal to negative cotangent of 3 phi. Okay, so clearly the left-hand side is the side that's ugly. But let me color code, so I'm going to call the numerator sine of 13 phi plus sine of 7 phi. So I have the sum of two sines, which I'd probably like to write as a product in the numerator, and then I have the difference, cosine of 13 phi minus cosine of 7 phi, that is the difference of two guys in the denominator. So the numerator, the sum of two sines, let's go back to our sum to product. So that's the third entry here. So that's going to be 2 sine of the sum, cosine of the difference. So I can write the numerator now as 2 times, what was it, sine of the sum? Let me do this in a different color. Oh, actually, I guess it doesn't really matter. No, I'll keep it in the same color. 2 times sine of the sum, all over 2, times cosine of the difference, all over 2. And we're dividing that by, now cosine of u minus v, what was that again? That's his second identity, which is -2 sine of the sum, sine of the difference. Okay, so in the denominator, I'll have -2. What was it? Sine. What color should I use? Sine of the sum, sine of the difference. So sum over 2, sine of the difference over 2. Okay, hopefully, maybe give myself a bit more room here. Okay, so what do I have? I have 13 phi, and 7 phi, 7 phi. Similarly, in the denominator, I have 13 phi and 7 phi, 13 phi and 7 phi. Okay. So what does this give us? The 2's reduce, but I'm left with a negative. It looks like these signs are exactly the same, so they reduce. And I have left cosine of what amounts to 13 minus 7 is 6 phi over 2. So that's 6 phi divided by 2, all divided by sine of, well, what do we have? 13 minus 7 is also 6 phi. And we're dividing that by 2. Okay, so what does this give us? This gives us a negative cosine of 3 phi divided by sine of 3 phi. Okay, well, cosine over sine is cotangent, and there's a negative out here, so this is minus cotangent of 3 phi. And is that what we were looking for? Yes, it was. So we've established the identity. Check mark.